Good morning children, welcome back to our chemistry classroom. So today we are going to discuss some in-text questions and answers from the chapter Carbon and its Compounds. Let's move to the first question. So here is the question, it is from page number 61. Question number 1, what would be the electron dot structure of carbon dioxide which has a formula CO2? So we know that from the chemical formula we can understand that one carbon is making covalent bonding with two oxygen atoms. That is why it is CO2. Okay. So the electronic configuration of carbon is 2,4 and oxygen is 2,6. Okay. So to get the octet, they bond in this way. You can see from the diagram, the carbon atom is making covalent bonding by sharing one pair of electrons with each oxygen. So it is making double bond with oxygen atoms on both the sides. Okay, is that clear to you? So it is double bond. Why it is double bond? Because two pairs of electrons are shared on both sides. Okay, alright. Hope you understood it. So we'll move to the next question. It is from page 61, second question. What would be the electron dot structure of sulfur, which is made up of 8 atoms of sulfur? So one hint is given here. The 8 atoms are joined together in the form of a ring. Okay. Now sulfur is a polyatomic molecule. What is a polyatomic molecule? We know that helium, argon, neon, krypton, xenon, etc. The inert gases are monoatomic. They don't want to combine with any other atoms, isn't it? So they make monoatomic. That means they can exist alone. Why they can exist alone? Because their electronic configuration is stable. Okay, for example, neon 2,8, isn't it? Argon 2,8,8. Okay, so they are having octet already in the last shell. Therefore, they do not combine with any other atoms. Okay. Now, in the case of oxygen, nitrogen, hydrogen, etc., they are diatomic. It means two atoms combine together to form a molecule of that element. Okay. For example, O2, N2, H2, etc. But some molecules are polyatomic. For example, sulfur. Sulfur, one molecule is combined by 8 atoms of sulfur. Now, this is the diagram of sulfur molecule. You can see the electrons of one atom of sulfur is represented with blue color dots. So the electrons of the adjacent sulfur atom is represented by red dots. So you can understand it very clearly. So on both the sides, each sulfur atom is making single covalent bonding. By sharing one pair of electrons on both sides, it is making covalent bonding. So sulfur is having atomic number 16. Therefore, its electronic configuration is 2,8,6. See here, out of that 6, for example, if you take the sulfur atom, you can see total 8 red dots are there. Okay. So, 2 of them are making single covalent on both the sides of the sulfur atom. Just draw and learn. Okay. So, we'll move to the next question. It is from page number 68. Okay. So, question number 1 is from omitted portion. So, I didn't include that. Question number 2 is what are the 2 properties of carbon which lead to the huge number of carbon compounds we see around us? So, it is tetravalency and catenation. You know already. Tetravalency means 4 valencies. Okay. What is catenation? The ability of carbon atom to form long chains, branch chains, or even in the form of closed structures. Okay. We'll move to the next one. From page number 68, question number 3. What will be the formula and electron dot structure of cyclopentane? Okay. Molecular formula of cyclopentane. We know that general formula of cycloalkanes are CnH2n. So pentane is having 5 carbon atoms. Therefore, the molecular formula is C5H10. Okay. Now, this is a structure of cyclopentane. If you draw the structure of any organic compound, you can draw the electron dot diagram very easily. See here, each carbon atom having 4 valencies that we know. So 2 of them are bonding with adjacent carbon atoms and 2 are making covalent bonding with hydrogen atoms. Okay, so this is the structure. So from the structure you can easily draw the covalent bonding. See here, so I'll take this carbon, see this carbon. So 5 carbon atoms total. Each carbon atom is making covalent bonding with the adjacent carbon atoms and with 2 hydrogen atoms. Just draw it and learn. Okay. So we'll move to the next question. Okay. It is also from page 68. Question number 4. Draw the structures for the following compounds: ethanoic acid, bromopentane, butanol and hexanal. Okay. This is ethanoic acid. What is ethanoic acid formula? CH3COOH, and the distribution of COOH in the structure is like this: C double bond O and OH. Okay, and one CH3 is attached here. This is the structure of ethanoic acid. Hope you understood. Now bromopentane. Okay, bromopentane. So we know that pentane is having 5 carbon atoms and 1 hydrogen atom is replaced by bromine. So it can be anywhere. Okay, here the name is simply bromopentane, so you can draw the bromine anywhere. The IUPAC name of this compound is 1-bromopentane because bromine is connected to the first carbon atom. Okay, first carbon atom. I told you, you can count from any side, either from this side or from this side. So as bromine atom is attached here, we will start from here. Okay, if bromine is attached here, what will be the name? It will be 2-bromopentane, right? So you can attach anywhere as the name is only bromopentane. Hope it is clear. Now this is butanone. Okay, butanone means 4 carbon atoms will be there, and among that 4 carbon atom, 1 will be of functional group's carbon atom. So remember, when we have a compound with a functional group that includes a carbon, while naming we are counting that carbon atom also for naming. For example, here including the ketone group, 4 carbon atoms are there. Okay, this is not propanone, this is butanone. What did you understand? That is, when we count the carbon atoms of an organic compound that contains a functional group which is having another carbon, you have to include that carbon also for counting. I mean, we are counting the total number of carbon while naming. Okay, that is why this became butanone, not propanone. CH3, CH2, CO, CH3. Clear? Okay. Now hexanal. Al means aldehyde. What is the functional group? CHO, right? CHO. Okay, if you got any confusion in functional group, go and watch the previous video that where we are discussing functional groups. Okay, so it is CHO. We know that CHO is a terminal group. At the end only it will come. Okay, so what happens? Here we are attaching CHO. This is the structure, C double bond O and H. Okay. Now, including this carbon we are counting. Okay. 1, 2, 3, 4, 5, 6. Isn't it? So, hexanal. Now you can write CH3, CH2, 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 CHO. Our molecular formula C5. Okay, C5, H11, CHO, or even you can add these carbon and write like C6H12O. In some question papers, it is coming like that. All the similar atoms are adding together and showing. Hope you understood. Page 69. How would you name the following compounds? Okay. So what is the name of this compound? Okay, it is bromoethane, right? From ethane, one hydrogen is removed by one bromine. Therefore, it is bromoethane. Second one, see here, what is the functional group? It is CHO, right? Okay, CHO. So, it is al. Which al? Only one carbon. Therefore, methanol. Isn't it? Methanol. Okay, the one hydrogen atom is attached here. Therefore, it is methanol. So, what is the structure of methanol? It is HCHO. Don't forget. What is this? Okay, this is an alkyne, right? Where the triple bond is attached. It is attached on the first carbon. Okay, first carbon. I told you you can count from any side. So, when double bond or triple bond comes, you have to give preference for that one. And we will start counting from that side. So we have to count from this side, like 1, 2, 3, 4, 5, 6. Okay. So this is the first carbon. On the first carbon, triple bond is coming. Therefore, it is 1 hexyne. Total 6 carbon atoms are there. Therefore, it is hexyne. Where the triple bond is attached, first carbon, it is 1 hexyne. Okay. Now we will move to page number 77 to 78 exercises. Okay. Here is question number 1. Ethane with the molecular formula C2H6 has how many covalent bonding? So just draw the structure and count the covalent bonding. Each line represents one covalent bonding. See here 1, 2, 3, 4, 5, 6 and 7. So 7 covalent bonds are there. So if you are asked to write the number of covalent bondings in any molecule, just draw the structure and count the number of covalent bonding. Clear? Here it is 7 covalent bonds. Moving to the second question. Butanone is a 4 carbon compound with a functional group. So we know that in butanone, including the functional group, the name is given. Okay, it is on, isn't it? So ketone, ketone is coming. This is the structure of butanone and the functional group is ketone. Okay, question number 3 is from omitted portion. So we'll move to the question number 4. Explain the nature of the covalent bond using the bond formation in CH3Cl. So we have to explain, simply explain the nature of or about covalent bonding in chloromethane. What is CH3Cl? It is chloromethane. From methane, CH4, one hydrogen is removed by chlorine atom. Therefore, it is chloromethane. Okay. Now, we are simply explaining about all the atoms. We know that in CH3Cl, carbon is having atomic number 6, hydrogen 1, chlorine 17. And the electronic configuration, carbon 24, hydrogen 1 and chlorine 287. Okay. Now we are discussing how they are making depends upon the electronic configuration. Okay. So we'll move to the next page. Here is the diagram. The diagram continues in the second page also. So you can simply write 3 hydrogen atoms complete their shells by sharing 3 electrons, 1 electron each of carbon atom. See here. So hydrogen atom needs 1 more electron. So they are sharing with carbon atoms. 3 electrons of carbon atom is making bonding with each hydrogen atom. Okay. And the 4th valency of carbon is making a covalent bonding with chlorine atom. Okay. So here chlorine completes its outer shell by sharing its 1 out of 7 electrons with 1 electron of carbon atom. Okay. So you can write in your own words. Thus carbon atom shares all its 4 electrons with 3 hydrogen and 1 chlorine and completes its octet. Okay. Single covalent bonds are formed in CH3Cl. So you can write, you can use your own words to explain this one. Okay. Now this is question number 5. Draw the electron dot structure for ethanoic acid, propanone, H2S, hydrogen sulfide and fluorine molecule. Okay. So if you know the structural formula of any organic compound, it is very easy to draw the electron dot structure. So whenever you are asked to draw an electron dot structure of any compound, you can first write the structural formula, then you can move to its electron dot diagram. Okay, see here, this is ethanoic acid. See, the functional group is COOH. So the distribution is like this: C double bond O, then one single bond with next oxygen, and a single bond with oxygen to hydrogen. Okay, and here CH3 is coming. So every single line represents one pair of electrons are shared, and double line indicates two pairs of electrons are shared. So you can simply draw this one. See here, carbon, out of four electrons, three of them are bonded with hydrogen, and the fourth one is bonded with the next carbon, and this carbon is making a double bond. Therefore two pairs are shared here, okay, with this oxygen, and the fourth electron is shared with a single bond, making a single bond with this oxygen, and here also one single bond is made. Just draw and learn. Okay, there is no shortcuts for learning the electron dot structure. Just draw and learn. Okay, similarly propanone, you can draw the structural diagram first. It is CH3, C double bond O, CH3. According to that, you can try the electron dot structure. If you get any doubt, we will discuss in the coming class. Okay, just inform me, we will discuss it. Hydrogen sulfide, this is hydrogen sulfide, H2S. Okay, so two hydrogen atoms are making single covalent bonding with sulfur on both the sides. See here, this way. And the last one is fluorine. Fluorine is F, single bond F. Okay, one pair of electron is shared in between two fluorine atoms. Just draw and learn, otherwise simply by looking you will not get it. You have to draw and practice, right? This is question number 6, the last question. All other questions given are omitted. So here question number 6 is, what is a homologous series? Explain with an example. So we know that homologous series is a group of organic compounds having same functional group and similar chemical properties, in which the successive compounds differ by SEH2 group. Moreover, they can be represented by the same general formula also. Okay, now the characteristics are, we know that all members of a homologous series can be represented by the same general formula, right? For example, alkanes can be represented by CnH2n plus 2. Okay, and any two adjacent homologous differ by one carbon and two hydrogen, that is CH2, in their molecular formula that we know. So molecular mass, the difference in the molecular masses of any two adjacent homologous is 14U. What does it mean? We know that in the case of homologous series, each successive member differ by a CH2 group. So what is the difference in the molecular mass? CH2 means one carbon and two hydrogen. One carbon is having an atomic mass of 12U. Okay, and one hydrogen 1U, isn't it? Two hydrogen atoms are there, so total 2U. So 12 plus 2, 14U. So their masses will be different in 14U. Next one, all the compounds of a homologous series show similar chemical properties. Why? Because they have the same functional groups. And the fifth one is, the members of a homologous series show a gradual change in their physical properties with increase in molecular mass. We know that boiling point, melting point, etc. they show a gradation, isn't it? In a gradual change with the increase in molecular mass. Okay. Now you can write any one homologous series also. Some examples. For example, here I have given the first continuous 5 members of alkanes. See here, molecular formula and name of the compound is given. Methane, ethane, propane, butane and pentane. Okay, each of them are differ by a CH2 group and their molecular mass differ by 14U. Clear? So our chapter is over. Now we have to discuss the nomenclature of organic compounds also. So that I will make another video and post it. We will move to the next chapter soon. Hope you understood the exercises clearly. Alright, we will meet in the coming class. Take care. Bye-bye. Thank you for watching.